Hey guys, welcome back. Today in day 7 part 2 we will talk about trailing closures. And it's all about the pass a closure expression to a function as the function's final argument. Okay, so let's start our playground. So the previous playground was for closure and the sorted method. So I'm gonna save this, close this and going to playground. So I create a blank playground and I'll go to document. I believe, yeah, learn iOS. The last one was closure number 1. This one gonna be closure number 2. Okay, and here you will see actually this gonna be this subject, sorry, here you go, gonna be trailing closure. Yeah, so trailing closure. Okay, so let's go to our resource, which is swift.org, and under language guide, closure. Okay, so trailing closure, what is that? If you need to pass a closure expression to a function as the function final arguments, and the closure expression is long, okay, and closure expression is long, it can be useful to write it as a trailing closure instead. It happened, in object in JavaScript. It's happened a lot that we have to open parentheses, after like this. So in Swift we have trailing closure option. So it can be useful to write it as a trailing closure instead. A trailing closure is written after the function call parentheses, even though it is still an argument to the function. When you use the trailing closure syntax, you don't write the argument label for the closure as part of the function call. Here you go. So here we have our example to make it more clear for you. So here you will see this is function take closure. Okay, so this is our function that take closure. So this is closure and this is the closure, we put it here. And here is how you call this function without using a trailing closure. So this is the function and this is the closure. So we can just write the closure here, okay? But if you want to do it in a trailing way, we just close parentheses here like this and pull out our closure just right after the function. This is feature that only Swift provide for us. The string sorting closure, which is was our example, is so reverse name. We said names is not made, yes, because I need it's a new one, so I need an array to work in it to try to sort it. Yeah, so let me write down my array here. Okay, so now we can use sorted function. Instead of writing this guy inside with trailing closure, we can pull this out. Said reverse names is not declared as well. How come? Because we said reverse name is equal this. So use unresolved identifier reverse name. Did you mean reversed index? No. replace reverse name with real index. No, this is not the case. So probably we need to write reverse name. Just let's see, reverse name. First time we wrote it by this way. Let me write this, see if it solves my problem. This is the complete way. Oh, sorry. Yeah, because it's not the first time. Yeah, I forgot to write var here. That's why. It's assumed that it exists, and I'm doing overwrite it. But first time you will write this. Like this. We need to have a variable because it was the first time in this playground. Okay, so let's go and continue. So this is for sorted method. Even though we can remove parentheses as well. So here we go. Now this time, because it exists, I just override it. So even we can remove parentheses like this. Okay, so these both working. Okay, now we want to talk about another method. We use trailing, which is useful for another method in Swift by the name of map. So trailing closure are most useful when the closure is sufficiently long that it is not possible to write it in line. It is possible but very difficult to track on a single line. In a single line. As an example, Swift array type has a map method. So Swift array type has a map method which take closure expression as its single arguments. Okay. So now the closure is called once for each item in the array and return the alternative mapped value possible of some other type for that item. The nature of mapping and type of the return value is left up to closure to specify. Okay, so now I make a dictionary here by the name of digital names. Okay, and I use map to do these changes on it. So here I say, okay, a string is gonna be map of numbers. In what way? That's return and a string only in number equal number, output equal nothing. So we do this for numbers and divide them by 10 while number bigger than 0. So this guy return 1, 6, 5, 8, and 5, 0. So if I want to know a string, gonna be 1, 6, 5, 8, and 1. So 1, 6, 5, 8, and 5, 1. So see what is doing this? The map method calls the closure expression once for each item in the array. You do not need to specify the type of closure input parameter number because the type can be inferred from the value in the array to be mapped. In this example, the variable number is initialized with the value of closure's number parameter so that the value can be modified within the closure body. The parameter to function and closure are always constant. The closure expression also specifies a return type of a string to indicate that the type will be stored in the mapped output array. Closure expression build a string called output each time each time it is called. It calculates the last digit of number by using reminder operators, number by 10, and use this digit to look up and appropriate string in digit names dictionary. The closure can be used to creating a string representation of any integer greater than 0. And here there's a note that says that we will have exclamation mark because it's output could be nil, so will be optional. So the string retrieved from digital names dictionary is added the front of the output, effectively build a string version of number in reverse. The expression number by 10 give a value of 6 for 16, 8 for 58, 0 for 510. So the number variable is divided by 10 because it is an integer. It is rounded down during division. So 16 becomes 1, 58 becomes 5, and 510 become 51 by 10, yeah? The process is repeated until number is equal to 0, and which point the output is returned by closure and is called the output array by map method. The use of trailing closure syntax in the example above neatly encapsulate the enclosures function nullity immediately after the function that closure support without need to wrap the entire closure within the map parentheses method alter parentheses. So yeah, let's look at the function. So we have this, and the numbers we have 16, 5, 10. So it's gonna say 1, 6, 5, 8, 5, 1, 0. Here we go. Let me add one more. 8, 1, 5, and see what it's doing. It's gonna be 4, and here we go, 8, 1, 5. So this map for us gonna make this to text by just using this dictionary and divide them by 10 and find the reminder by 10. So I hope you get that and it's been useful. And in next part we will go over capturing value, which is very important. So this section that we've been over, it's very trailing closure. It will be interview question if they're looking for senior or even intermediates. Even sometimes for beginners they're gonna ask this. And capture for beginner, senior, intermediate, and senior level, it could be a question, and where you need to be clear about that. So don't miss next part. Okay, that's it for today. I hope you like the video. If you like it, please make sure to give it thumbs up, and also don't forget to be subscribed for more video all coming every day. And if you have any question, please ask in comment below. I will be more than happy to help you and answer your questions. And I wish the best for you. Have a good one. Bye bye.